Hello students, in this part we are going to discuss about application of concept of circles that we have learned in the previous lectures. Now we are going to start with a very basic concept that we have learned in the previous lecture, like the circumference of a circle. That is, when a particle is completing a circle, what is the length covered by that particle. Now the application of circle is very common in our daily routine life. Now you can see that the minute hands, second hands or the hour hand of our watch is completing a circle. Motion of earth around sun can be considered approximately as a circular motion. If a string is fixed with a stone and if I rotate that string, then the stone is covering its path as a circular path. Now there are some other examples also very common, like when you are making a turn in a road, that smaller part of that turn can be considered as a part of a circle or segment of a smaller part of a circle. So here I am going to start with some basic concept of circular motion. Now you have learned that the circumference of a circle whose radius r is given as 2 pi into r. Now let us say a particle is moving along a circle. Now let us say the particle starts from point A and then it completes the circle and again come back to the point A. Now what is the value of distance covered by that particle? So the distance covered is simply the length of this circular part, that is 2 pi r, or the circumference of the circle. There is another quantity which is called displacement. So what is this difference between distance and displacement? Distance is the length of the path covered and displacement is simply the shortest distance between 2 points. If I want to calculate the displacement during a full completion of a circle, it will come out to be 0 because the initial and final point are same here. But if I want to calculate the displacement of a particle during half of the rotation of a circle, then you can simply see that the distance is pi into r, while the displacement is simply the length of the diameter, which is simply 2r. If a particle rotates from point A to point P, that is smaller segment of the circle, which makes an angle theta at the center, then what is the value of distance covered? This you have been discussed in the previous lecture by Subbu sir. This is called length of the arc L. It is simply r into theta, where r is the radius of the circle and theta is the angle subtended at the center by the 2 points A and P here. So these are the examples of how we can calculate distance and displacement, two quantities. Similarly, let us say the time taken by the circle to complete the circle is given as capital T. Now, using the distance covered and the time taken by this particle, I can calculate the speed as well as velocity of this particle. I would like to invite Subbu sir to give you how we can calculate the value of speed and velocity. Velocity is simply displacement upon time. Speed is simply distance covered upon time in this case.
So if we see here, speed is actually equal to distance covered by time taken. So the distance is 2 pi r and the time taken to complete the rotation is t. This is the speed. If we want to find the velocity, that is actually displacement upon time, and in fact displacement as such has already told that in the complete rotation the initial and final point is the same. So displacement is 0. So the velocity is 0.
So a general thing I can say about relation between distance and displacement. You can also see here that distance is larger than displacement and speed is larger than velocity. The general thing that we can say about speed and velocity as well as distance and displacement is distance is always either greater than or equal to displacement. Speed is similarly either greater than or equal to velocity. Speed can never be less than velocity. Distance can never be less than displacement. So these are some basic example when we are using the concept of circle while various part of motion during circular motion in physics. Now, another concept that we have learned in the previous lecture was angle between two points is given as theta. Then the angle between direction of tangent drawn at those 2 points can also be written as theta. Let us say I am taking a point A here and I am taking a point B here. So these 2 points make an angle theta at the center. Then, as discussed by Subbu sir in the previous lecture, if I draw a tangent at point A and if I draw a tangent at point B, this is the direction of tangent at point B, this is direction of tangent at point A, then the angle between these two directions is also theta here. So I will apply this concept in calculating the change in velocity during a circular motion. Let us say we are considering a very simple case of uniform circular motion. What is the meaning of uniform circular motion? A circular motion in which the particle is moving with a constant speed. Speed is constant but velocity is continuously changing. Why it is changing? Because at each point the direction of its motion is changing and hence the velocity will continuously change because velocity is a vector quantity. Now let us say I am considering a point A here and I am considering a point B here, and these 2 points make an angle theta at the center. As discussed here, the angle between the tangents of these 2 points also make an angle theta. Now as you know from vector that if I want to write change in velocity, I can write this as velocity at point B minus velocity at point A. Here I want to calculate the magnitude of change in velocity. So here the detail of this formula can be discussed in some other lecture, but here I am just writing the formula of change in velocity. So it is under root of velocity of b square plus velocity of a square minus 2va vb into cos of theta, where theta is angle between velocity vector A and velocity vector B. Since the motion is uniform, I can say that the magnitude of velocity at point A and B is same. So I can write this as under root of v square plus v square minus 2 into v square into cos theta. So the change in velocity has a magnitude of 2v square into 1 minus cos theta under root. It is 2v square 1 minus cos theta. Now 1 minus cos theta from trigonometry, and you may learn this later when we discuss the concepts of trigonometry, that we can write 1 minus cos theta as 2 into sine square theta by 2. After taking the under root, I can write this as 2v into sine theta by 2 here. This is a very important result, and questions are being frequently asked both in the school exam as well as NEET or JEE Mains exam based on this concept. So some application of this concept will also be discussed in the next lecture when we apply other concepts of circular motion in various parts of physics. So for this lecture, it is good wish from us, and remember these two formulas that we have discussed here, will apply this in the next lecture. So thank you, students.